I'm Anil Kumar. Let me first thank my subscribers for taking keen interest and posting excellent questions. This is for you all asking to understand characteristics of polynomials. I have compiled a couple of multiple choice questions in this particular video where we'll discuss degree and end behavior. The very first question here is, state degree of the following polynomials. F of x equals to 2x times x minus 3 times x squared plus 5 x plus 3 whole cube, and g of x is 2x to the power of 5 minus 3x to the power of 4 plus x to the power of 6 minus x squared plus 5, and there are 4 different options. You can pause the video, answer the question, and then look into my suggestion. The purpose of writing polynomials in 2 different forms is that is what you see most of the time, right? You either see it in the factored form given above as f of x, or you see a sum of terms of polynomials as given in g of x. To find degree of a polynomial, if given in factored form, you have to add these exponents, correct? So for f of x, degree will be 1 is for x, right? If nothing is mentioned, it is assumed to be 1, right? Anything to the power of 1 is the same thing. So the degree is 1 plus 2, and this one is 3, correct? So just add them up to get 1, 2, 3, 4, and 3, 7. So the degree for f of x is 7. How about g of x? When you are given different terms, you have to look for the term with highest degree. In this case, x to the power of 6 is the term with highest degree. So the degree of g of x is 6. And therefore, the combination f of x degree 7 and g of x degree 6 is the right one for you, correct? So that is how we get the degree of a polynomial when it is given in different forms. I hope that's clear, right? So let's move on to the next one. State leading coefficient of the polynomial f of x equals to 3x times x minus 3 times 2x plus 5 whole square times 1 minus x whole cube, right? Okay, we have given a couple of options. You can again pause the video, answer, and then look into my suggestions. We are talking about leading coefficient of the polynomial. Now, how do you get leading coefficient? We have to multiply all the x terms to get the leading coefficient, correct? So one of them is 3x, okay. The other one here is x. Then we have 2x whole square. So this square is applied to 2x. So if you expand it, you get 4x squared, right, remember, plus 2ab, which is 10 times 2, 20x plus 25. So you get 2x whole square here, correct? And in this case, it is minus x whole cube. So it is minus x whole cube. So if you multiply, what do you get? So this is, let me rewrite this as 3 times x times x. And what is this? This is 4x squared. And this one is minus, let me write minus here, x cubed. So minus to the power of 3 will be negative, correct? Now you get minus 12, and x is 3 to 5, 6, and 7, x to the power of 7. So this is a 7-degree polynomial whose leading coefficient is minus 12, correct? So that is the answer for it. So do not ignore these things. It's very important to understand. Now, once you have all this information, I would like you to sketch this polynomial, right? Okay, let's move on to the next one, which is regarding the end behavior. So we have the same polynomial which we discussed in the previous slide. Here, you need to match end behavior of the polynomial. F of x is 3x times x minus 3 times 2x plus 5 whole square 1 minus x whole cube. Now to find end behavior, we have to figure out 2 things. 1, degree, and the other sign of leading coefficient. I'd like you to pause the video, answer the question, and then look into my suggestions, correct? Okay. Now here, as we did in the last video, let's first find out what is the leading coefficient. So we have 3x here, okay. Then we have x, and then we have 2x whole square, and then we have minus x cubed. So if you open this up, I know in this particular case, we are not really looking into the value of leading coefficient, but we can redo it, right? So minus 3 times 4, square of 2 is 12, so minus 12, x to the power of 1, 2, 3, 4, and 3, 7, right? So leading coefficient is minus 12, x to the power of 7. So degree will be 7, so it's odd degree function. And leading coefficient is negative. Do you see that? Negative leading coefficient. So if we have negative leading coefficient, in that case, what is the end behavior? Negative leading coefficient means right side down. 7 is odd number, right? Odd degree means opposite ends. Is it okay? So that is the kind of end behavior you expect for the given polynomial. So when x approaches negative infinity, y should approach positive infinity. So that is okay. This is also okay. When x approaches positive infinity, y should be negative infinity. So this one is y approaching negative infinity. So the option is C. Perfect. Now as a practice question, try to sketch this polynomial, right? So we'll get into sketching of polynomials in the next video, right? Okay, so let's move on and see the last example in this slide. We are again discussing the end behavior here. However, the equation is given in the other form, not factored, but in terms of combination of its terms. Match end behavior of the polynomial f of x equals to 3 to the power of 4 plus x minus 2x squared minus 3x cubed, right? And those are the combinations for end behavior. You can pause the video, answer the question, and then look into my suggestions. Again, let's identify the leading term, which is highest degree. This one, right? It is a constant 3 to the power of 4. It does not have any variable, so it does not define the degree of the polynomial. Remember that. It's just to confuse you. Okay. So here, the degree is what for us? Degree is 3, right? So that means odd. And leading coefficient is negative, so it is negative leading coefficient. Perfect. When it is negative leading coefficient with odd degree, we are looking for a polynomial. Negative leading coefficient means right side down. Odd degree means opposite ends. Do you see that? So we're looking for when x approaches negative infinity, y approaches positive infinity. When x approaches positive infinity, y approaches negative infinity. So the option is C for us. Is it okay? So that is how we can understand the characteristics of polynomials based on its degree and leading coefficient. So I'll take a few more videos like this where we'll discuss different concepts and thereby get good understanding on this unit of polynomials. I'm Anil Kumar and I hope you appreciate it. Feel free to subscribe and share my videos, and if you like, that'd be great. Thank you and all the best.